Hey guys, so today's lesson is about how can we convert between grams and particles or vice versa. So let's start with what we know. We know that in 1 mole there are 6.02 times 10 to the 23rd particles or things, and I know that 1 mole has a certain mass. We call that a molar mass. That mass is different for every substance because it depends on what my particles are. So all those things are equal, and the thing that they have in common is the mole. So I can convert from particles to moles and then from moles to grams, and we're going to call that a two-step process. But the thing that I have to remember is that I cannot go there directly. I cannot do that in one step. I have to go through moles. Okay, so two-step conversion problem. Let's do an example. Or here's a map of what that looks like. So grams is on one side, particles is on the other, moles is in the middle. If I'm going from grams to moles or moles to grams, I'm using molar mass. Or if I'm going from particles to moles or moles to particles, then I'm using Avogadro's number, which remember is 6.02 times 10 to the 23rd. I cannot go directly from grams to particles. That pathway does not exist, so I need to go through moles. All right, now let's do an example. So here's my problem. How many atoms of copper are present in 35.4 grams of copper? I'm going to underline what I know, 35.4 grams, and I'm going to circle what I'm looking for. How many atoms? How many particles? Okay, this does not anywhere say moles, but that's what I'm going to have to go through to get from grams to particles or to atoms. So here's how I set up my problem. And notice how my units are canceling out. So 35.4 grams is what I start with. That goes first. That's what I know. Then the next conversion is molar mass, and that's 2 capital M's is my abbreviation for that. The 63.5 grams came from the periodic table. The next conversion is using Avogadro's number. And my units are all canceling, grams is canceling out, moles is canceling out. So I am left with atoms for my unit, and my answer for all of that should be 3.35 times 10 to the 23rd atoms of copper is my final unit. So let's try another example using that same method. So how many molecules of carbon dioxide are present in 78.4 grams of carbon dioxide? This is what I know. This is what I start with. 78.4 grams of carbon dioxide. The thing that has to come next is grams, and 1 mole is on the top. So what is this number down here? This is my molar mass. So I have to calculate molar mass for CO2. There's 1 carbon and 2 oxygen, and so I just look those up from the periodic table. 12.01, 16.0, and 16.0. So I add those all together, I get 44.01 grams. Grams cancels. Then I do my next step. Moles is on the bottom now, and I'm looking for particles, so particles is on the top. Avogadro's number, it tells me that it's molecules. Nope, sorry. So molecules on the top, moles cancels. When I punch all that into my calculator, be really careful that you are pressing enter after every step and using your EE or EXP button. At the very end, I get something like 1.07 times 10 to the 24th, and my unit on that is molecules. Okay, that's my final answer. So now let's try another one on your own. Here's another problem for us to try. So what is the mass in grams of 5.30 times 10 to the 24th formula units of table salt, which is NaCl? This problem looks a little different now because this is what I know, which is particles, and I'm looking for grams. And so my steps are going to kind of be in reverse order. I'm going to start with what I know. 5.30 times 10 to the 24th formula units. And so my first conversion, if formula units is on the top to begin with, then formula units has to be on the bottom here. And 1 mole is on the top, 6.02 times 10 to the 23rd. Okay, so those units cancel. I'm left with moles, which isn't what I'm looking for, so now I need to get over to grams. 1 mole goes on the bottom next, and then my molar mass of NaCl. So 23.0 plus 35.5, which is 58.5 grams. Moles cancels, and I get a pretty big number here. I get something in the ballpark of 515 grams of NaCl. Okay, so pause and replay this as many times as you need to, but make sure that you can do these 2-step problems, and we'll see you back in class.